Hi, my name is Arvin Singh. This is my coolest project submission, designing a deep learning-based backyard squirrel detection system utilizing the Raspberry Pi. Every year, my family looks forward towards the month of May as our backyard donut peach trees then fill with delicious peaches. I first noticed the backyard squirrel problem I began remote learning due to COVID last year. Every day, I saw my grandma working tirelessly in the yard, watching for squirrels in an attempt to protect our peach tree. I decided to design and construct a system which autonomously detected passing squirrels and sent out alerts using Raspberry Pis. So the final concept involves two main systems: the detection system for testing and the verification system for visual verification. The detection system consists of a camera, which will be feeding a live video feed into the Raspberry Pi 4B, the main device used to run the detection model, which I will train. Along with that, I also include a Google Coral Edge TPU accelerator to increase the performance of the live stream. So upon detection of a squirrel, the Raspberry Pi 4B will then log that detection and notify the alarm system. So this is a quick look at the setup in which the devices are placed in a yard facing a wall, a common path for squirrels. Here's a diagram of my design. I include a few cooling fans to cool down the Raspberry Pi, since they can reach up to 60 degrees Celsius and significantly reduce the processing power and speed. I also included a solar shield and air vents to deal with other outdoor drawbacks. This is the alarm system, which consists of a Raspberry Pi Zero W, a buzzer, and an LED providing a visual and auditory cue. So moving on to the artificial intelligence training portion of my project, I retrained the last few layers of a published deep learning model called SSD MobileNet V1. In order to retrain, I prepared my images by creating XML files and trimaps from the original images. After my data preparation, I retrained the SSD MobileNet V1 model on Google Colab. In order to run my newly retrained model on the Raspberry Pi, I converted to TensorFlow Lite and Google Coral Edge TPU compatible model. I also made Python script changes to prevent false detection. Overall, the device was extremely successful. When testing the final model over a span of 3 days, it produced an outstanding 100% detection rate, capturing and recognizing every squirrel that passed through. Furthermore, it was able to detect fast-moving squirrels with a high confidence of 94% and stationary squirrels with a confidence of 99%. In addition, the model was able to accurately detect multiple squirrels simultaneously while ignoring background movement. The hardest part about this project was getting the artificial intelligence models and the Python scripts to work together. In order to get them working, I had to do lots of research and troubleshooting on topics that were new to me. In the future, I plan to create a public GitHub repository documenting the steps and code required to replicate my project. Lastly, I also plan to mention my device taking out the reference camera, which is only used for detection and verification.